So in today's lecture, we're going to introduce some of the commonly used functions in Python. Okay. So including how do you import a library to your code. You don't have to write everything from scratch. Okay. And then there will be some logic functions to be introduced today. So let me show you what I'm presenting today. Basically, what we're going to import is a library called math. Because we are mechanical engineers, we use math all the time. You want to have sine functions, exponential, logarithm. You want to have those. If you don't have a function like these, then sometimes it's difficult for you to compute some advanced math functions. So how do we do that? Basically, just import and math. Okay? So let's do that in Python, in Spider. Just import math. Okay? And for example, I'm going to compute a sine function. So if I say y equals to math dot sine bracket, I'm gonna give a number here. For example, sine 0. Let's see what the result is. And then I will print y. Okay? A simple function like this. Hold on. It's not. Okay. So, if I try a different value, for example, 30. So by default, 30 is not in the scale of, in the unit of degree. It's in the unit of, is radius. So you need to divide 30 by 180 and multiply pi, right? So you can use math.pi. There's actually a real pi value inside math. If you do that, then it's very close to 0.5. Still approximation, because the right answer is supposed to be 0.5. So when you use math.pi, it's a value very close to the real pi, but it's still approximation. And also, the sign they're using probably also approximation. What if I use the well-known 3.14 by ourselves? It's even less accurate. So from here you can compare. If you use math.pi, it has many digits behind it. It's much accurate than your own input. Okay? So you can just say, use math.pi for more accurate computation, but still not 100% accurate. It's like a 99.99999, how many nines percent accurate. Okay? So, this is the first thing I want to introduce today. You can see there are many available functions inside math. Maybe we can take a look. If we Google Python and math, okay? You can see a bunch of, let let me see if you can see sign here. Okay, see, sign function is one of the available method inside this math library. There are still a lot of them available inside this math library. Okay, so whenever you need to know what's available, you can always Google for it. Right now, you don't really need a book in order to learn Python. You can easily find something like this. Okay, it even tells you how to provide the input. Okay, so one example. What is A10? A10 is arctangent. Arctangent. So what is A10(2)? Arctangent 2. So for arctangent, basically there are two ways to provide a computer how to compute arctangent. Basically, is for tangent is y over x, right? Y over x is tangent, and the arctangent is the inverse operation of the tangent. So sometimes when people try to compute arctangent, they don't want to just give a single value because there is a issue of positive and negative. So if you want to precisely present arctangent, then sometimes people precisely mention, okay, what's the y and what's the x. So like something like this, then there is a available function called arctangent 2, and you provide a y and x. So you are truly computing the arctangent operation based on y over x, the exact y over x. Okay, so from here you can tell there's a difference. If you only give a value, basically the ratio of the result of y over x, then the result ranges from negative half pi to positive half pi. But for arctangent, it gives you, arctangent 2, you can get a result from negative pi to pi. Okay, so arctangent only provides 1/2 of the entire space, but arctangent 2 provides the entire space from pi to negative pi. Okay, so something like that. If you don't know what are the available functions, you can always Google for this. And there are even more complex functions like I just saw like this one. Okay, this one has many inputs. Then you can always check, okay, what's this for and how do you use it? Okay, but I'm not going to cover every method inside math. I'm not gonna just introduce you how to use it. And sometimes when you import a function, a library, maybe the library has a long name. You don't want to use this math dot something all the time. What you can do is you can import a library as a new name, a shorter name. So as something is a shorter name for your function only. So from now on, capital N represent the math library. So later on, you don't really need to say math dot. You can just say capital M dot. But once you do that, capital M becomes the library, not a variable, not a available variable. You cannot use the name of capital M. So let's see how it works. If I say as M, can I still use this? Because it is becoming capital N, I have to replace this by capital N to avoid error. Okay? If you run the code, it's the same thing. But you can see your code is becoming cleaner. Okay? So So let's try a different function. For example, z equals to m dot cosine. Let's try 60 degree by something like this. You can do sine and cosine. Okay? Let's try this. Please do sine and cosine. Pick your own degree. Try to convert degree to radius. Throw it into sine cosine and check if it's truly computing sine 30 and cosine 30 degree properly. Print out the result. Let's try it.
它甚至下面那盘子都有出现。
你说报进度跟角度，
就不找那个 PI 就是
没关系啊，我现在知道了。没关系。
应该很多人
So if you have no idea what is pi, pi is pi. This pi, pi n dot pi is the pi in math. 圆周率, okay, pi. I have no idea how to name this in a different way. Mathematical constant, that is the ratio of the circles. Yeah. So you know pi has infinite amount of digits after the dot. And for computer, it keeps a memory of how many digits are there. So, if you are confused what I'm doing, what is 30 over 180 multiplied pi? Okay, I guess some of you may not understand what's going on. Okay, so usually when we say sine 30 degree, right? We will know the answer is one half. But for human, we know this is in the unit of degree. But for computers, usually they don't like the input in the unit of degree. They like the degree, they like the unit in radius. Often just said red. Or if you have no idea what is this, in Chinese is 进度, right? You learn this in high school maybe. So how do you convert 30 degree to radius? Divided by 180 degree multiplied pi. Okay? Because 180 degree is pi. So pi is in the unit of radius. So if you after you do that, this whole thing becomes in the value in the unit of radius, and you will put everything inside sine. So you want to do this. So this is 1/6 of pi, basically pi over 6, right? You are truly computing pi over 6, not 30 degrees. You need to tell the computer pi over 6. What is pi over 6? Basically 3.1415 over 6. For computer, he assumes you will do this for sine 30 degree. So you have to do this conversion. Okay? Just for you to know if you have no idea what happened. Okay? Is everyone okay? Okay, let me continue. You may need more time for today's exercise, so I want to continue. So I can give you more time later on. Now, what are some other available functions inside math? Let's go through every one of them. What is CEIL? Basically, ceiling. Ceiling is like on the top of your building, ceiling, right? In math, ceiling means 无条件进位. If you have to learn in Chinese, okay, ceiling is a mathematical operation that will advance the value to 1 if it's some value like a 0.4. So let's try it. Why is that? Sorry, M. So, ceiling of 0.4 is 1. What is floor? Floor is the floor, right? Basically, in Chinese is 无条件舍去, if you need Chinese. So in English it's flooring. So if you do that, flooring of 0.6 gives you 0. Okay? FABS. F is like a very commonly used starting a symbol, a character for something that you want to get a function or a value. ABS are the 3 characters in front of absolute. So this is like F of absolute. So you are trying to get absolute value, 绝对值, okay? So if I say C equals to M dot F absolute negative 2.4, print C. If I do that, I get 2.4, absolute value, okay? And there are some others, exponential, power, logarithm, SQRT. What's SQRT? Square root. Square root. So SQRT is square root. 开根号. Cosine, arc cosine, distance, D-I-S-T, distance. Computing the distance of, basically computing the length of a vector. So it's like a y squared plus x squared plus y squared, and then take the square root. Okay, so if you have a vector, you want to compute its length, you can use this distance, right? Let me see if they have norm. There's no such a thing called norm. What is norm? In math, in the future you will learn what is norm, or maybe you already know what is norm. So, norm of x. Norm, this is norm, okay? The English of this operation is called norm. Okay, so basically square root of all the component, taking the squares, sum of the square of each component, and then take a square root. That's called norm. This is how you compute the length of a vector. Okay? But in Python, there's not a function of norm. It's called n dot distance, but it only computes two-dimensional vector. So it's actually telling you what it does. If you check on the hint over here, dist, right? It tells you it computes square root sum of px minus qx squared for px. Yeah. It tells you what it does, right? So whenever you will have a function, you can always take a look at the hint to understand what this is for. And sometimes the issue is what you're trying to do is norm, but you don't know the name of the method inside Python. So sometimes you need to go online and check what are the available functions. What's the name they use? Okay, each language use different names for those functions. So for example, to compare, in MATLAB, ABS is absolute. In MATLAB, you can use norm. There's a function of norm already. Okay, so different language use different names for the functions. Different library use different functions, different names for the methods. Okay, so I just want to let you know there are some other available functions that you can use. There are many of them. Many others you can use if you Google for it. Okay, like seeding, right? We did seeding already. Let me see if they have round. I think it has round. Yeah. Oh no, they don't have round. So what is round? Let me see. Round is like a Cicero rule. Okay. Do they use truncate? Really? Truncation. Okay. Let's see. No, not truncation. How did they do rounding? I'm so very curious. Python has round already. You don't need. Okay, let's see. Really? Okay, Python already has round. That's why math doesn't have to do rounding. Okay. So like small knowledge like this can be found on internet. But you need to be curious about it. Otherwise, there's no one can tell you what to do. Okay? Internet is your best friend for programming. Now we know how to do rounding. Okay. So those are the available functions. Let's see what I want to do for today. Pi, we already talked about pi. This is basically, yeah, we don't need this. Okay, some exercise. Okay, let's do the exercise later on. Let's continue to talk about what we are going to do. So there, I don't think you need to practice this, right? It's very easy. Just like sine and cosine, different functions. Okay. Now I want to get back to the PowerPoint, and let you know some of the not so obvious operations that can be done in Python. So plus and minus, they are very easy to understand. This is multiplying, this is dividing, okay? So 1 divided by 2, the result is 0.5. You get floating results. But if you have / twice, it only gives you integer results. Let's try it. So if I say f equals to 3, how about 10 divided by 3? And then g equals to 10 / 3. Let's print out the result. Okay? The result will be different. So if you only have 1 slash for dividing, then by default, it's going to give you floating results. So the answer is 3.333. But if you use / it's integer result, so only 3. Okay, how about let's try 11. Okay, if I do 11, so you need to be careful right here because I didn't know actually. If I use 11 divided by 3, it's 3.333, 3.666. But if I use / it's a result with flooring. 无条件舍去 flooring. So it doesn't, it's a result after a flooring, not rounding. So if I use 11 / 3, because the result is supposed to be the rounding of 3.66, it should be 4. But in fact, Python is doing derivation and then remove everything in the back. Okay? So you can also say it's like a derivation removing the remainder. Okay, what's the remainder? Remainder is like the 余数, okay? So if I say h equals to 11% 3, okay? Right here, remainder, okay? Print h. So remainder is what's remaining after you do the division, okay? So this is 余数, right? So this is like if you want to divide 11 by 3, you should get 3 with a remainder of 2. So this is how you can get the integer result, and this is how you get the remainder. Okay? How about, let me see. This is power, right? Let's try this. Yeah, basically this is a power. Okay? Let's try it. Yep. So star is like a power. Okay? 次方, okay, power. So if I do 2 * 0.5, basically is square root of 2. Okay? So those are very simple. I think you don't need to practice. Just for you to understand. Okay? Let's move on. There are some other available mathematical operations that you can do. This is available in Python. You don't need math. So, okay, absolute. We already have absolute. But I think there's a difference. Let me see. If I say print ABS, I think this is okay. Then I don't know what's the difference. Let me see what's the difference. Python math.fabs. So how come math function needs a fabs? Okay. Returns absolute value as a float, but ABS also gives a float. Is it? Let me see. So J is also a float. So I don't think Python version basically the same. Basically the same. I don't see there's a I see. So if you have the Python absolute, let's say your input is -1, at the end it becomes an integer. But if I have a J1, is a Python absolute, and J2 is math.f absolute. Also, f represents floating number. Now I understand. So f absolute is basically the answer has to be floating number all the time. So you see J1 is an integer, but J2 is a floating number. So f absolute always return in floating numbers, even if your input is an integer. Okay, so that's the difference. That's why math library would like to create this kind of function. So max and min finds the maximum value inside a series of input. Min finds the minimum one. Let's try it. So if I have max 1, 2, 3, 4, and 5. Print. Okay. So the largest one is 5. Okay. Let's try K1 equals to 1, 2, 3, 4, and 5, and K2 equals to max K1. Print K2. So even if your input is a list, K1 is a list, right? You can max and provide a list. You don't really need to list all the components inside the method. You can provide a variable of a list. How about a tuple? Can I do this in a tuple? So K4 is the max one from the tuple. So even max, your input for the max is a tuple, it works. How about the dictionary? Maybe not. If I say A, comma, no, I need to say this. 1, B, 2, C, 3. Oh, 3. So if I say K6 equals to max, and now K5, I don't know what's gonna happen. K6, is the key with the largest value. This is the first time I tried this, okay? If you use max function for a dictionary, then in return, it's going to find the maximum value and then return the key for that value. Then I'm curious what will happen if I say D also equals to 3. What's gonna happen? The last one. Okay, how about A equals to 3 as well? Okay, so it seems like the last one, the last key for that largest value will be found. How about K5? Do we have sort? No. Dictionary has no sort. Yeah, so what I guess was for the max function, it will search from the first key to the last key, and then if there's a last key, then the last key will be shown. So that's why, as a result, D was shown. That it has the largest value, but the last key. That's what I guess. How about mean? Let's try mean. So definitely it's gonna be, it's A. Then I'm not sure. Why is that? K4 is one correct, but minimum of K5, it says B. It says A. Then I'm not sure. Maybe it's just computing the. Okay, I think min or max for the dictionary is very weird. Maybe it's just counting the index. Which one? So if I say the values, then definitely we can find it. It's 2. Because if I say K5 dot values, it's gonna be a collection. It's going to be a value object of the dictionary. So inside this values, it will be a collector of 3, 2, 3, 3. So definitely you can find 2. But how about keys? It will be weird if we do that. I'm not sure what's gonna happen. Because for the keys, they are just A, B, C, and D. So maybe the character A is the smallest. So maybe when I do this, it's actually checking on the keys. The A was the smallest key. So if I replace like this, so probably the answer is still A. Yes. So min max, if you directly put dictionary inside min and max, it will study the keys. And even though they are characters, there is a representing value behind the character. A is smaller than D. Okay? Let's try something else. If I use a different symbol, like a special symbol. One of it is, oh, you cannot use this one. Try this. The smallest symbol is this one. Because it has a representing value behind each character. So I think what Python is doing is comparing the representing value behind the symbol. So what does it mean, the value behind the symbol? I think it's so-called the ASCII code. ASCII code. For every symbol, there is a let me see, ASCII code for like this. So there are, for every symbol, there's a number behind it. So computer recognize those symbols with numbers, known numbers. Okay? It's not very clear. How about this one? That's why they can compare the size between symbols. Like this one. Maybe it's better resolution. Okay? So every character, there is a number behind it. Okay? So I'm curious about the ASCII code of this. Which one? We can. Okay, the dollar sign is 38, I think. And how about the, oops, that one is good. Hold on. Let's try to see sharp. Okay, sharp. This is called sharp. Dollar sign. And then percentage. And the and sign. So if I'm right, number-wise, the sharp sign should be the smallest. So let's try it. Okay, see the sharp. If I try to check which one is the max one. So if it's based on the ASCII code, the and sign has the largest index for the ASCII code. So see, the max one is the and sign. So every character has a value behind it. If you use min or max on dictionary, and it will compare the size, which one, I should say, it will try to compare the keys. And in this particular case, there are 4 characters. Each of them has a representing ASCII code. So I think Python is comparing, because for character, there's no way to compare. So it's comparing its ASCII code. Okay, so I think that's enough for min and max. So we can also do power instead of star star. You can have power 2, 3. So at the end, you should have 8. Okay, you can have power. Same result if you say 2 star 3, that's the same thing. So you also have 8. Okay, no difference. Let me try 3.1. Same thing. Exactly same thing, no difference. Okay? Now, we already introduced round. Okay, we can also do rounding up to certain place, certain digit. So you can have, you cannot use n anymore. N equals to, let's say, something like this. And you can say round n 2. then you have 2 digits behind the dot. If you say nothing, then by default, it's 0. It's like you're doing this. No, then you see the 1 dot. So by default, it's like this, okay? Okay, so those are basic mathematical functions that you can use. And there's something very important also in programming. What we did earlier was to have some numerical operation. Now, there's something for you to compare, like a comparison operation, okay? So these are the ones that we use inside Python. What does square mean? Equals mean, not square. Equals mean. Okay? So equal basically is like a kind of check that checks whether the left and the right are the same. So if you say something like this, 1 equals 2, it will be false. 1 equals 1, true. So what's interesting is that you can do something like this. O equals to 1 equals 1. So what is O? O is true. O is true. So this is a kind of operation to check whether this is the same as this. And for the result of your check, save inside the variable O. Okay, so whenever you see this equal sign, then it's a kind of operation to check. So you can also have 1 larger than 2, 1 smaller than 2, 1, what else? Larger than or equals to. So 3 larger than or equals to. Four smaller than or equals to. Something like those. What else? We can have something like not equal to. How do you do not equal to? This is how you do not equal to. Not equals to. So let's say 3 not equals to 4. Let's see the results. So the first one, yes, 1 equals to 1. Second one, no, 1 is not larger than 2. So the result is false. The third one, 1 smaller than 2, yes. Another one, 3 larger than or equals to 3, yes. 4 smaller than or equals to 5, yes. Is 3 not equals to 4? Correct. So the results are Boolean algebra, Boolean numbers. Okay? True or false? Okay, we need those later on. I will give you a little time to practice. You don't need to practice the whole thing. I'm gonna show you. You did this already. Because I did a lot of print, I don't think you need the print. I want you to practice those without the print. Otherwise, it's too many. Okay? You can try. Try to observe what's gonna happen for those. Okay? We tried many different things. Let me review what was done. We tried ceiling, flooring, floating absolute, rounding, divided by, the integer part of dividing, the remainder of dividing. This is power, so we did this already. Absolute. We don't need, I can get rid of this because there's a practice on the top. Absolute. Picking a max from a list of a bunch of input. Picking a max from a list, from a tuple, even from a dictionary. Okay? Power. We don't need this. Okay? Power. And then the comparison. Try those, you can just play with your own number, that's fine. Okay, I will give you 3 more minutes. Those are just for simple practice. Okay, I think that's enough practice. If you are not finished, that's okay. There are just some functions for you to know. There are more important things to introduce for today. That's called the logic. Okay? So I'm going to show you something called if logic. So I need to show you the screen. So in Python, or many of the programming language, you can do something called if logic. So what's happening is, if something happens, we will do what you describe inside the logic. Okay? And in some other cases, you can have so-called the if logic. If this is true, do this. Otherwise, do something else. Okay? So it's easier for me to introduce, to explain this directly in Python. So let me just create a new file. This is for so-called the if-else logic. I'm gonna clear the memory. It's easier to restart. So I'm going to provide a number. Random number. I think it's called a random integer. Let me see. I forget about the random number. Let me see. It's inside random. So there is a library called random. Okay. Random integer. So I'm calling a different library called random. For me, I'm going to make it, for short, I'm going to use capital R for random. So inside random, there's a random integer, okay? And you can say range from -1 to 1, okay? And I'm gonna print x. Actually, I don't want integer. Let me see if I can have random floating numbers. Random. Okay, I need to check. Python random floating number. Just rand. So I don't even need a library. Just rand. Okay. So x is rand. It will give me a random number from 0 to 1. Okay, that's good. So just this. No. Random, okay. Random. Oh. Okay, I need to know why. Python random. Oh no, it's also, I think it's inside the library. Random. So I still need to import random. Okay, so random gives a number from 0 to 1. The result is a floating number. Okay, I still need to import the random library. So I'm gonna do something called if loop. If x is smaller than or equals to 0.3 column, you need to put a column here. I'm gonna print and say x, comma, is smaller than or equals to 0.3. Okay, let's do this. So since this time is not, so it doesn't print anything. Try it again. Try it until, okay. I made several tries. In one of the solution, in one trial, the last trial I did is truly less than 0.3. Then on the screen I show the result like this. Okay? And how about so-called else? If you want to, it's like otherwise. If this is not happening, I will do another thing. So in this case, I will say larger than. Okay? So when I print, this time it's larger than 0.3. Let me try it multiple times. Larger than, okay, smaller than. So with this logic, you can either do the first thing or the second thing. How about a 3-level check? There's something called else if. And x is smaller than 0.6. It's not else if. In Python, it's called elif. is actually else if, okay? So, if you do that, this actually means EL if means else if. Okay? So in this case, I'm gonna print. I'm pretty sure it's gonna be larger than 3 because this will happen only if the first situation is not happening. So I'm pretty sure it's larger, definitely larger than 0.3 and smaller than 0.6. So in the range of 0.3 and 0.6. So for the else, I have to say definitely it's larger than 0.6. So I cut the range from 0 to 1 into 3 parts. Let's see the results. So this time is in the range of 0.3. Now is in the range of larger than 0.6. So in this case, this is within 0.3 and 0.6. So using this if, else if, and else, I can determine, I can check whether those conditions are true or not. Okay, so this is the first check. You need this to return true or false. So you can try something else. You can say y equals to x smaller than 0.6. So we practiced this earlier. This is a kind of comparison operator. The result is true or false. You can replace this by y, because y is a true or false. Let's try what will happen. See, this time it's the same code, because this is an operator to see whether the number is smaller than 0.6. But there is a slight difference. Actually no, this is fine. This is fine. So I just replaced x smaller than or equals to 0.6. It was here. I use a variable to replace it. You can even have a Boolean variable right here as the check. Okay? So please try those. Try this. One case is that you can have direct checking operation right here, or you can have a Boolean variable on the top and then use it for the condition. So please try this. I will give you the screen. By the way, I want to show you something. Let me just another display. So there is a difference if you write a code inside the loop or outside the loop. Let me show you. Let me find a situation. Okay. So in this particular case, our value is 0.46 is in the range of the second operation, right? So after this line finishes, it will not go to else. It will directly go to line 12. So in the line 12, I just showed, I want to print end of code. But there's one more line right here. It's actually inside the else. So if you want to do something inside one of the logic, in Python, you need to have this tab. You can do multiple things. Inside this else operation, I'm going to do two things. I'm going to print this line, also print finished. Let me show you when the else, when the value jumps into the else situation. Over here. This time my value is 0.94. It's inside the third region. So both of these two lines are executed. You see this result, you also see finished. And whatever that's outside, of course, it will be done all the time. So if you want to do something within this condition, you can write it over here, but you need a tab. So for example, if I want to do, if I say print and say hello, you will see error message because you are not supposed to jump out of the loop if the loop is not finished. So you have to put a tab, then no error. Okay, in this case, if I, like this one, the number is within 0.3, so this second line, hello, was executed. It was run. Okay? So can you tell the difference? Okay? If you want to do multiple things, you can do it for the following after the condition. But you need a tab right here. Can you do this? No, it has to be 4 spaces. A tab is a 4 space. 3 space is not good. Python recognizes the 4 space. Basically a tab. Can you have 5 space? No. It has to be exactly 4 spaces in front of whatever you want to do. So Python recognizes, okay, this is inside the loop. Okay, get back to you. This is very important. Please make sure you practice this.
好像等
打一下粉丝码，在我拍摄里面，然后我会。
Any question? If you have question, you need to let us know. Okay, are you ready? So that was the if and else if. I'm going to teach you one more thing, then we can do the exercise. So for if and else if something is happening, do this, otherwise go here. If the second condition happens, do this, otherwise go to the third one. So this was, oh, I need to share the screen, sorry. Final thing I want to introduce. Let me review again. If something happens, do this. Not satisfying, go to here. If I have a if there's a if-else operation, if the second operation condition happens, then do this. Otherwise, do the else. Okay, that was if, else if, else. Now, there is another thing called while. While operation. So for the while operation, let me show you what does while mean. So it's easier if I just show you what is while. I have a number called x. It starts with 1. While x that is smaller than or equals to 10, I'm gonna print x and say x equals to x plus 1 and the end. What does that mean? Let me show you. Clear the memory, clear everything here, run the code. So what happened? X at the beginning, x equals to 1. When you go to this line, while this is happening, do whatever that is in the bottom. So while x is smaller than or equals to 10, okay, do this. So over here, I print out the x. Then I advance x by 1. I add x by 1. So x now becomes 2. What happens to while is that it will not stop until it's finished. So it will go back to line 2 and then repeat everything. So because x now becomes 2, it is still satisfying the check. 2 is still smaller than 10. So it goes back to the third line and then print out. So this repeats until the last time. When x becomes 10, 10 still equals to 10, so print out 10. So now x becomes 11. When x equals to 11 and goes back to the second line, because it is not satisfying anymore, it will finish this loop. So maybe I will say print and say finish right here. Then you will see a finish at the bottom. Let's run the code again. You will see this finish. What if over here I say print not finished? Then you will see not finished all the time, but 10 is too many. Let's try 5. Okay? Then you will see 1 not finished, 2 not finished, 5 not finished. Because when it was 5, we will go through all this. 5, print out 5. X equals to 5 plus 1, so x now becomes 6. But you still print out this line and go up to here. 6 larger than 5, so directly goes to line 6. So you will see these results. So this is the while loop. I need you to practice the while loop. Okay, you can practice this one. Once you are done with this one, I will show you what I want you to do for the exercise. Okay, so get back to it. Practice while, practice if. I'm going to copy all these to here so you can practice at the same time. Practice everything, okay? I'll give you 10 minutes, then we do the exercise.
我被检举，但是他的车，所以记点是记他。哇呀！
然后他的错应该是用到全形或半形。
Are you finished?
对，真的。他这个就有就会想到40，代表说每张434，所以那就会有出错。那如果是指数的话，那种
Do you need more time, or do you want to start the practice, the exercise today? Who needs more time? Who wants to start today's exercise? Okay, so someone raise your hand. Thank you. Okay, so if you want to continue, here's my example for practice. But I'm going to give you the exercise for today. You probably need to pay attention to the exercise. Okay? It will need you to combine if logic and while logic together inside the code. So this is what I want you to work on. I want you to solve. Oh, actually, let me finalize something. It's okay to show you the result. Let me see why. 1 plus x, 1 plus x. So. Okay. Yep. Okay, good. So, let me explain what the problem is about. And I will show you my code. So don't worry, don't be scared. So, inside Python, we have this math library. You can solve for complex mathematical operations such as logarithm. However, by programming, sometimes you don't really need the library. You still can solve for logarithm. In math, there's something called Taylor series, right? So Taylor series basically is a summation of something with multiple terms, infinite number of terms. So you basically do this for infinite number of terms, sum them together. Then you get very accurate approximation of logarithm. So when you do this, this is just like doing a while loop. Every time you plug in the index number n. Next time, use index number 2 and 3 and 4. Do this repeatedly until you satisfy and then sum them together. So I want you to practice how to do this in Python using while loop. In order to ask you to practice if loop as well, I want you to do the following. First, inside the code, you are going to say a number x and give a number n. This number of n doesn't need to be an integer. But for the math, we need the index to be integer, right? So we are going to, basically what we are trying to do is, so what we are trying to do is to estimate logarithm of 1 plus x, starting from an index of 1 until we reach a given number, capital N. Oh, I should use capitalize. So here should be, let me see, double check the math. Should be, here should be like this. This should be I, this should be I. Yep. Okay, this is more accurate. So, given number x and the number of n, this n is going to be the index, the maximum index for this estimation. You can have a very large number like 1,000, okay? But usually this number has to be an integer. If you don't provide an integer, you provide a floating number. So the next thing I want you to do is to use the if loop. I should use capital N, sorry. If this capital N is not integer, then we will set capital N as the rounding of capital N. So if it's a floating number, we just push it to an integer. Then we work on the while loop. For the while loop, you need to start with some index. I use small I right here, but basically is the small n. Okay? So some index I, you want to start with 1. Inside the while loop, you are going to compute -1 power of I plus 1 times whatever x you assign. So x plug in power of I, just like the equation, divided by I. You're going to compute this for every index. Index 1, and then do the while loop, index 2, index 3, 4, 5, 6. And at the end of the while loop, make sure you increase the index by 1. Otherwise, your while loop will not stop. You will jump into so-called the infinite loop, infinite while loop. So keep on doing this until when? Until the I index reaches the max number you assign. Then stop. So sum those numbers together, you will get a pretty good estimation of logarithm of 1 plus x. Finally, use the math library to do the same thing and compare their difference. Okay? So let me show you how it's done in Python. I'm going to show you, because if I don't show you, you probably cannot leave. So I will show you. But after I show you, I hope you can try it on your own, okay? Let me just show you on the screen. Here's my code. I will explain what I did. I import math as capital M. I give a number x equals to 1. I give a capital N. This is going to be the max index I'm going to use. I intentionally make it floating. For the if loop, what I did here is n divided by 1, checking the remainder. So let me show you. 2 divided by 1, checking the remainder, it's 0. 2.1 divided by 1, checking the remainder, it's 0.1. So if whatever you have divided by 1 and checking the remainder, if it's not 0, that means your value right here is not an integer. So if that happens, I will do the rounding. Okay? Then I will start with an index of 1. I use a memory of y. Later on, everything I compute, I will memorize it inside 1. So this is my while loop. If the index I is not reaching the maximum number, I do this calculation. So basically, this is the memory. The y start with 0. Every time I add the -1, this is power of I plus 1, right? Why do I have a float here? Because I want to make sure I'm getting floating number. If I put integer, I worry. Python will just give me integer results. So just float my I, multiply, this is x. Oh, I should say float I as well. Actually, I think maybe it doesn't matter because they are floating numbers. So anyway, -1 power of, let me try to remove all the floating numbers. Let me see the result. I guess Python will compute this as floating number. So maybe I put some space here so you understand what I'm doing. Okay? -1 power of I plus 1, just to compare here. This is this part, -1 power of I plus 1, right? And then multiplying x to the power of I. X to the power of I, divided by I. So this whole thing will be kept inside y every time sum this term. And then you advance your index by 1. This loop will not finish if this index is not reaching capital N. And then once it's done, print out the result. If you do it by the math library, it's going to be math logarithm 1 plus x, but the logarithm right here is logarithm with natural number at the bottom, right? So it's n dot e is natural number. Okay? So remember, usually when we say log x, usually we say, we assume it's log 10, right? But when we say, in Taiwan we call this long, but I'm not sure in USA they call this long. Long x or log x is actually natural number at the bottom for x. So log x is actually using the natural number for coefficient. So n dot e, math dot e is the natural number. 自然对数, okay? Then show the result. So from here, if you have, you see, by the estimation it was 0.69 something, by Python also 0.69 something. If I reduce the capital N to 10, then the estimation was less accurate. If I only have the power of 2, only 2 terms, it's very non-accurate, very poor. So we want this to be large. For example, this. So if you have 124 of those terms summed together, it's very accurate. Okay? That's what I want you to work on for today. Try this. Do I keep this on the screen? I think okay. I will keep this on the screen. So you don't really need to say float I, because when you have -1 power to the I plus 1, the result is a floating number. You don't really need to say float. Okay. And I probably need to, I will show you something like this, and then I will show you the problem. Okay, so I'll give everything back to you. Once you're done, you can raise your hand and ask the TA to check. Any question for this? Computer crash? Any? Yeah, the TA is coming. You can challenge yourself by doing the left-hand side without my help. You can try this by yourself, then compare to my code. My code is just one example. Okay, you don't really need to do the same thing. You can try different ways.